Okay, let's actually investigate the kind of notation we're going to see when we see second derivatives. First off, if we have a function of x and y, there are two partial derivatives you can take with that. We're going to do the subscript notation first, and then we're going to do the fraction notation after that. Those are the two partials with respect to x and y. Now, if I want to start taking partial derivatives of those with respect to x and y, right, there's going to be four partial derivatives. So let's just say, if I want to take the partial derivative of each of these with respect to x, what am I supposed to do? Well, how does this notation work, right? In order to write down the partial derivative of this with respect to x, I'm supposed to write down that function, right? And then I'm supposed to put a subscript x next to it like that. And so what you're going to see is fxx, which says start with f, take the partial derivative with respect to x, and then take the partial derivative of that with respect to x. If I want to take the partial derivative of fy with respect to x, now how does this notation work? You write down the function like that, and then you put as a subscript the variable that you want to take the partial derivative with respect to, like that. So this says start with f, take the partial with respect to y, take the partial of that with respect to x, and then you're going to get fyx. So you can see that this notation actually goes from left to right. You start with the function, take the partial with respect to y, take the partial with respect to x. If I now want to take the partial derivatives of each of these up here with respect to y, we know how the notation works. We just write down the function, and then as a subscript, we write the variable that we want to use for the next partial derivative. Normally they'll write this without the parentheses. I'm not always fond of that, but you get like that. And again, you're going to see this notation works from left to right. You start with the function, you take the partial derivative of that with respect to x, take the partial derivative of that with respect to y. Finally, if I want to take the partial derivative of fy with respect to y, we know how this notation works, right? We write down the function, and then as a subscript, we write down the variable that we want to take the next partial with respect to, right? This notation works from left to right. We start with the function, we take the partial of that with respect to y, we take the partial derivative of that with respect to y, and then usually write this without any parentheses. All right, so that's the easy one to write down. That's not the one that most of the sciences use. The next one's longer. Now, how does the other one look? Well, basically, there's this notation. And what that actually says is the partial derivative of, right? And when we write this, we write that's the partial derivative of f with respect to x. And so we would write partial derivative with respect to x like this. Again, this means partial derivative of with respect to y. And I write like this. And they'll often write it like this. This is the kind of notation we saw when we were doing second derivatives in Calc 1. Now, these are going to be longer. Well, we'll see. If I want to take the partial derivative of this with respect to x, what am I supposed to do? I'm supposed to write down the partial derivative of, and then the function we're going to take the partial derivative of. Now this notation follows the same usage you actually saw with second derivatives in Calc 1. What they're going to do is really abuse the notation. On the top, it looks like partial squared f, and that's what they're going to write. Like that. On the bottom, it looks like partial x quantity squared. What they're going to do is just drop the parentheses, and they'll write it like that. It's not my favorite notation, but biology and chemistry really want it. Meanwhile, if I want to take the partial of this one with respect to x, what I'm supposed to do is say, let's take the partial with respect to x, and then put in the function. Like that. Now again, they're going to abuse the notation. It looks like the top is just partial squared f. On the bottom, there's no way to do that really. This is partial x, partial y like that. But you can see that this notation almost works from right to left, right? Because this says start with f, take the partial of that with respect to y, and take the partial of that with respect to x. This is backwards of what the other notation was. If I want to write down the partial derivative with respect to y, the second partial with respect to y, I'm going to say let's write down what we're going to do. So we say let's take the partial with respect to y, and then we write the function we're trying to take the partial derivative of. So partial f, partial x like that, And again, we're going to use notation. The top just looks like partial squared f. That's what they're going to write. We're not squaring anything. On the bottom, this looks like partial y, partial x. And again, you see this notation actually works from right to left, because we start with the function f, we take the partial with respect to x first, and then we take the partial with respect to y. Finally, if I want to take the partial of partial f with respect to y, I'm going to say, well, I want to take the partial with respect to y, and then we write down the function. So I'm going to get partial f with respect to y. And again, we're going to use notation. The top just looks like partial squared f. That's horrible notation. Nothing's being squared. On the bottom, it looks like I have partial y times partial y. And if they were at least honest about the way they abuse notation, they'd put in parentheses for that, but they don't. They don't do that in Calc 1 either. This is consistent with the way they abuse the notation in Calc 1. Yes. Now, this one and this one, the notation makes more sense, right? It's just take the partial of the function with respect to x twice. This one's take the partial of the function with respect to y twice. This one and this one, you have to be careful about the way you read them, right? Those are called mixed partials. They're very important. We'll talk about those later, but they show up in integration, they show up in optimization. It's kind of cool. But anyways, this is the notation for second derivative. We won't be doing third derivatives or fourth derivatives very often this semester. And when we do, we'll probably try to use the other notation just to stop from being confused. But this kind of notation is what they like to use in the sciences. It's explicit about the variables. They really like those variables just showing up exactly where they should be. That's the notation for second derivatives.